All right, so now we are continuing into doing something very, very interesting, and that is called nuclear chemistry. Whenever you hear or read the word nuclear, you know we are talking about the nucleus. If we're in physics and we say nuclear physics, it is related to the nucleus of an atom. So the same thing is happening here in chemistry. We've been looking at chemical reactions where we were dealing with things that are outside of the nucleus. Electrons bonding, right? It was the electrons that were involved when we were talking about bonding. Nothing to do with the protons, nothing to do with the neutrons, because these are inside the nucleus. But now we are going into into chemistry where we are looking inside the nucleus and not outside of the nucleus. Okay? Remember that the nucleus is just a very small part of your atom. So now we are looking at the changes that happen inside the nucleus of an atom. And when we deal with them, we call them nuclear reactions. Nuclear reactions are the reactions that happen and cause changes inside the nucleus of an atom and not outside. So we're going to be looking at totally different particles. We're not going to be talking about electrons, okay? Although we'll be talking about something which is very similar to an electron, which we can a lot of the times represent as just an electron. We'll see when we talk about the particles. But right now we are looking at the chemistry of the nucleus, okay? Inside the atom, we're inside the atom. Now, right now, the first thing that I've done as we are going into this topic is to make you understand the difference between the chemistry you are starting to do now and the one you've been doing, which is the difference between the nuclear reactions and the chemical reactions. All right? Exactly. So I've listed down about 5 key differences between nuclear reactions and chemical reactions. Chemical reactions are what we've been doing all along, looking at the electrons, okay, and how the reactions, many reactions that are happening, but all of them were to do with electrons, okay, redox reactions. All these other reactions that we talked about are based on electrons. Now we are looking at the nucleus. So here let's list the first thing, the first key difference between chemical reactions and nuclear reactions is the part of the atom which is involved in the reaction. For chemical changes, we're talking about electrons, the outer shells. So even from the beginning of your year one, you'd look at the electronic configuration, SPDF notation. It was to do with electrons, right? And the shells and all about them. Now we are looking at the nucleus. So we'll be dealing with the nucleus. The what is involved in the reactions for nuclear physics? The nucleus, things that are in the nucleus. Those are the ones we'll be focusing on only. Second, so the first is the involvement, and we've seen that here the involvement is the electrons that are in the outer shells. So we'll be knowing about the outer shells. But for nuclear changes, nuclear reactions, which is what we are looking at now, it'll be the things that are involved inside the nucleus. The protons are now involved, and the neutrons as well, and many other particles. We'll talk about them. Now, energy changes. The second difference is in energy changes between the two. Chemical changes do not normally involve a lot of heat or a lot of energy. Not much energy is involved in these reactions. All right? A small amount of heat or light or whatever. But when it comes to nuclear changes, nuclear reactions come with a lot of energy. Very large amounts of energy are involved in nuclear reactions. Whenever you hear something, they say we have a nuclear reaction or nuclear bomb or whatever. There's a lot of energy involved there. All right, a lot of energy. And okay, so one was involvement. We saw what part of the atom is involved. Now we saw that in chemical reactions, not much energy is involved, but in nuclear, there is a whole lot of energy. Types of reactions. Types of reactions. In here, we have the formation or breaking of bonds or breaking of bonds. Those are the type of reactions that we have. two things coming together to form something else, okay? Whatever the type of reaction could be, hydration or whatever, or oxidation or redox, or reduction, we have these types of reactions, many of them. But for nuclear, the types of reactions that we have are not related. They're not related to the formation or breaking of bonds, but rather what we have is radioactive decay, one, another one, fusion, another one, fission. And there are many other, like nuclear bombardments, where we talk about transmutation. It's going to be very important. I'll list it to you again. The types of reactions that we are now talking about. And we are going to be grouping our work, where you need to see that right now I'm dealing with this part, then this part, then this part, then that part. Okay? So you're going to talk about radioactive decay, and it's a part of nuclear reactions. So nuclear reactions, we have radioactive decay, we have fusion, we have fission, and we have other nuclear bombardments that are not fusion and fission, like transmutation, which you are going to have to know as well. All right? I'll show you the important ones that you will be questioned on. Understand it? Now, the other thing that is different between these chemical reactions and nuclear reactions is going to be how they are affected by external factors. For the chemical reactions that we have been dealing with all along, these are affected by or influenced by external factors like temperature. Changing the temperature is going to change the rate. It's going to change it's going to change how fast your reaction is happening. Changing the pressure is going to change how fast your reaction is happening. All these are the external factors. But nuclear reactions or nuclear changes are not affected by external factors as much, especially when we talk about radioactive decay. Fusion and fission, we're going to see that they are affected, although it's not as much as the chemical reactions. Chemical reactions are on another level when we are talking about how they are affected by external factors. Now, the last thing which we talk about is what is conserved in these guys. In chemical changes, mass is conserved, right? But in nuclear reactions, when we look at the reactions, we know for chemical reactions that mass is going to be conserved. The mass of the reactants is exactly equal to the mass of the product. Mass does not change in a reaction. What just changes is what you now have. You could be combining hydrogen and oxygen to form water. But the mass of the hydrogen and the oxygen combined should give you should get the same amount of mass if you measure the mass of the water that you're going to get. So the mass is conserved. Now, for nuclear changes, the mass is not conserved alone, okay? The mass is not conserved. Although when you look at the reaction, you may not see it because the mass that is changing may not be that great. Einstein showed us that, let me say something. In nuclear reactions, when we combine the mass and energy of the reactants, it is going to be equal to the mass and energy of the products. So we say mass energy is conserved, which is the sum of mass and energy. If you combine the mass and energy of the reactants, it's going to be equal to the mass and energy of the product. But if you combine the mass alone of the reactants, it is not going to be equal to the mass of the product. The products are going to have less mass because some of the mass is going to be changed into energy, and not even much of it, okay? Not much of it though, simply because you don't need a lot of mass to get a lot of energy. That's what Einstein showed using his equation, E energy is equal to mc squared. This c squared is going to be very, very big, such that it can change just a little bit of mass, okay, small amount of mass into a whole lot of energy. So yeah, that's something. Now, one thing I see which is not there is charge. I want you to know that charge is conserved for both of them, okay? Both of them, charge is conserved. Charge is conserved when we talk about chemical reactions. When we talk about these redox reactions, the total charge of the reactants should be equal to the total charge of the product, as well as the nuclear reactions. When we talk about nuclear reactions, we don't care what it is, we know that the charge will be conserved as well. In other words, the charge of the reactant will be exactly the same as the total charge of the product. Right. I hope you understood. These are some of the key differences between nuclear physics. Oh my gosh. Between the nuclear chemistry that we are now talking about and what we've been talking about all along. Chemistry of the chemical reactions. So these two are different. They involve different parts of the atom. For chemical reactions, it's the outside of the nucleus, which is the shells where the electrons are in. We're talking about bonding, electrons coming together or being donated, and then these two atoms then come together after the donation. Or in nuclear chemistry, we are now talking about something happening to the nucleus. The nucleus is going to be changed. And when it's changed, we'll get a different guy because you have altered the composition, right? We'll get something that is different. It could be a different element or it could just be a different isotope. So we're going to have to make you know. Be very confident in your knowledge of an isotope because we are going to be dealing with it a whole lot. All right? Bye for now. See you in the next video.